Hi guys, this is lesson 6.3. It's called Elimination using addition and subtraction. So we're going to be solving systems of equations by using a technique called elimination. And we're going to be doing that with some addition and some subtraction, and I'll show you what that means. Here's an example. In Chicago, Illinois, there are 2 more months A when the mean high temperature, mean means average, is below 70 degrees than there are months B when it is above 70 degrees. So they gave us a system, A plus B equals 12 and A minus B equals 12. And just as an overview, one technique that we can do to solve these equations is to add them together. So instead of trying to substitute or graph, which is the things we've done before, we're just going to add these things together. So notice that if I add 1a and 1a, I would get 2a. And if I add a positive b and a negative b, they would become 0 and go away. And then I can add the 12 plus 2 and get 14. So notice that I have done my objective in solving systems, which is to eliminate one of the variables so that I can solve for the other one. I can finish solving this and I will get a equals 7, and then I can take this 7, plug it back into the equation, and solve for b. All right, setting that aside right now, right here you can see elimination using addition. If you add these equations, the variable b will be eliminated, and using addition or subtraction to solve the system is called elimination. So key concepts here. Step 1 is going to be to write the system so that the like terms with the same or opposite coefficients are aligned. So notice that I put them right one on top of the other, so the a's lined up and the b's lined up and the numbers lined up, the constants. And then step 2, we're going to add or subtract, which will eliminate one variable. And I'll show you what happens when we're subtracting. I have a little bit different way of looking at that. And then step 3, just like before, we're going to substitute the value that we got in the first part of this into one of the equations and solve for the other variable. So remember that systems are all about finding where lines on a graph cross. So we're looking for a point, an x and a y. So far, we have solved systems by graphing them and just looking to see where the lines cross. And then we solved by using substitution. Now we're going to use elimination. Remember that we can only solve for one variable at a time. Sometimes adding or subtracting 2 equations will cause one variable to cancel, allowing us to solve for the other variable. So that's what we're working on today. Here's the first example in the book. We'll just briefly look at that. If we have 4x plus 6y equals 32 and 3x minus 6y equals 3, you can see right here that I have a plus 6y and a minus 6y. That's awesome because when we add these 2 equations, those 2 things will cancel out. We end up with 7x equals 35, and we can finish solving this to get a value for x. Then we can take either one of our original equations and plug in that 5 and solve for what y is, ending up with a value for where the 2 lines cross. This is consistent and independent. All right, let's see. I'm going to skip down to the next one here. Look at this example right here. Sometimes they're not lined up correctly. So look at this. See how the T's and the R's are not lined up correctly. So let's go ahead and rewrite that like that, and we'll put the 2T here and the 9R and equals 22. So see how I rearranged that so that they line up one on top of another. So you can subtract. That's fine. But what I like to do is I like to always add. And it's okay if you multiply, if you take, say, 2t plus 9r equals 22. If I were to multiply everything in this equation on both sides by a -1, notice that I'll just get this, -2t minus 9r equals negative 22. So I like to do that instead of trying to subtract, because sometimes I get confused as to whether I'm subtracting or adding, and the positives and the negatives get all messed up. So here's what I'm going to do. Before I try to add them, I'm just going to change every sign in this equation. I'm allowed to do that because of this. It's what I did here, and I got this little guy right there. So it's super easy to just change the signs in every single piece of this equation, and then I'm going to go ahead and add. So 2t and negative 2t cancels, that makes a 0. 5r and negative 5r makes negative 4r. And then I have 6 plus a negative 22. So we're going to end up with, let's see, 6, negative 16. And we can finish solving this by dividing by negative 4. And we'll get that r equals 4. Okay, see, notice that they got the same thing when they subtracted. I just like to handle the numbers the way I handle them so that I'm not going, oh gosh, was I going 6 minus 22, or was I going 6 plus negative 22? For me, it's just easiest to add every single time. All right, so you can see that they got their r, they plugged their r back into an equation, and they got their t, and they found their solution to that system. All right, so let's work a couple problems. Write down this system and pause the video if you're watching this by yourself, and then turn it back on to see how you did. Okay, so what I'm going to do, because I already have a positive 8x and a negative 8x, is I'm just going to go ahead and add my two equations together. This makes a 0, and this makes a 7y, and this makes a 42. So I don't really need that 0 there. So let's just think about 7y equals 42. I need to divide by 7, and I will get y equals 6. That's half of my answer. I need to choose one of these equations. Doesn't matter which one. Let's say we chose 8x plus 5y, and let's plug in a 6 instead of the y, equals 38. So I have 8x plus 30 equals 38. Subtract 30 from both sides. 8x equals 8. I'm going to divide by 8 and get x equals 1. All right, so I now have an answer. It is this. We'll put the x first. It's a 1, and the y second. It's a 6. Sweet. All right, let's do another one. What if I have this problem right here? 5m minus p equals 7, and you're writing this down because you're going to solve it before you watch me do it. 7m minus p equals 11. All right, so I will give you a little bit of a hint here. There's a little bit of a problem because both of these are negative. If I add them together, I will get negative 2p. So what are you going to do about that? Go ahead and pause the video and see if you can solve that on your own. All right, so what I'm going to do about this is I am going to multiply my entire second equation by negative 1. That's going to make this negative, it's going to make this positive, and it's going to make this negative. And I do that because I want to add my equations. I don't want to mess with subtraction. So I just want to add them. Notice that 5m and negative 7m are going to give me a negative 2m. Negative p and positive p are just going to give me a 0, right? And 7 and negative 11 gives me a negative 4. All right, ignoring that plus 0 because it really doesn't affect us, I want to divide by negative 2 to get m by itself. And so I'm going to get m equals a positive 2. All right, that's half the work. So I need to put m equals 2 into one of my equations, and it doesn't matter which one. 5m, I'm going to put a 2 instead of the m, minus p equals 7. I may not have chosen the easier one because the plus p might have been easier. I don't know. I like positives as long as I can keep them. All right. I know I'm not going to want to have a negative p anyway, so at this point I might just add p to the other side, and then I have p plus 7 or 7 plus p. You don't have to do that, but in the end you're going to have to multiply or divide by a negative to make that p positive. All right, subtracting 7, and we get 3 equals p. So I have my answers now, and I get, let's put those in alphabetical order because that's generally the way things are. LMNOP, so we'll put M first, that's 2, and P is 3. When in doubt, go ahead and just write this. M equals 2, P equals 3. That way there's no confusion over which is which. All right, let's do another one. Suppose I have 7F plus 3G equals negative 6, and I have 7F minus 2G equals negative 31. Again, turn off the video, pause the video, you work it yourself, see if you can do it, and then turn it back on to see how you did. All right, I want to add, so guess what I'm going to do? I am going to look all the way through my second equation, and I'm going to change every single sign. I'm going to multiply everything by a negative. Okay, notice you have to make a change in front of every single number. All right, now that I've done that, I can just add them. 7F and negative 7F makes a 0. 3G and 2G makes 5G. And negative 6 and positive 31 is going to be positive 25. Ignore that 0 plus because that doesn't really affect anything, and let's divide by 5 to get G equals 5. All right, I've got an answer for G. I'm going to plug it in somewhere. Let's go ahead and do 7F plus 3 times 5 equals negative 6. So we have 7F plus 15 equals negative 6. Subtract 15 and get 7F equals negative 21. Dividing by 7, I get F equals a negative 3. All right, I should have a complete answer now. My answer, A, B, C, D, E, F, G. So we're going to put F first and then G, or when in doubt, just list them. G equals 5 and F equals negative 3. All right, let's go ahead and do another one. 6A minus 3B equals 27, and 2A minus 3B equals 11. You stop the video, pause the video, work the problem yourself, see how you do. Hopefully it's making a little more sense every time you try one. All right, so again, I have negative 3B and negative 3B. If I add those together, I'm going to get negative 6B. So let's multiply every single number here by negative 1. So positive 2A becomes negative, negative 3B becomes positive, and positive 11 becomes negative. So what I did there was I times everything by negative 1. Okay, and that looks like x minus 1, but I meant times negative 1. We'll just say times negative 1. That makes a little more sense. All right, so I am going to add my things together. 6A and negative 2A is going to give me a positive 4A. negative 3b and positive 3b is 0, and 27 plus negative 11 is going to give me a positive 16. All right, and then ignoring this plus 0 because plus 0 means really nothing. Let's divide by 4 on both sides. Whatever I do to one side, I have to do it to the other side, and I will get a equals 4. That's half of the work, so I'm going to grab whichever equation here. Just for fun, I'm going to go with my original 2a minus 3b equals 11, just for fun, because you could use the negative 2a plus 3b equals negative 11. You could use the 6a minus 3b equals 27, or you can use this. We're going to say 2 times 4 minus 3b equals 11. That's 8 minus 3b equals 11. I need to get b by itself, so let's start way out here with the 8. Because it's a positive 8, I'm going to subtract it. Don't get confused by the 8 minus 3b. That minus goes with the 3. All right, so 8 minus 8 is 0. That's why we did that. I'm actually going to write that so you can see that's what I was trying to do. And 11 minus 8 is 3. Okay, so 0 minus 3b just means minus 3b. So I'm going to divide by negative 3 because this is multiplication. The opposite of multiplication is division. And so I'm going to get b, negative divided by negative is positive, b equals negative 1. All right, I do have an answer now. My full answer, a is 4 and b is negative 1. All right, hopefully that's helpful. Remember that what we did today was elimination using addition and subtraction, only I made the subtraction into addition by multiplying by negative 1, just because I like to do just adding. This is called elimination because we eliminate one variable so that we can solve for the other variable. And then using that information, we can go back and find our second variable. We need to find both of them, but we can only find one at a time.